Okay, hello everyone. Welcome to CS 109. I'm glad that you're here. So although we have a really nice weather outside today. Okay, so on Tuesday I talked about multidimensional data visualization. So if you just take a table, it could be of different dimensionality, could be a large table, small table, but then we talked about the different techniques that you could then use to represent that. We talked about parallel coordinates and heat maps. We also discussed the limitations that you have there. And in the second part of the lecture, I actually briefly covered maps and text. So if you get in the situation that you're not just dealing with numbers, but you have geospatial data or just text that you scrape from the internet, then these techniques are really useful for you. Okay, today, in the first about 25 minutes, I'm going to talk about big data visualization. Yeah, and big data visualization, it's, first of all, I have to define what's big data. Yeah? And then I'm going to talk how people can visually handle this amount of data. So I'm not going to talk about how to handle this using dimensionality reduction. This will be the second part of the lecture that Raphael is going to teach later on. Yeah, so Raphael will introduce the concept of distance, then he's going to talk about clustering. So if you want to create groups according to some similarity in the data that you have, and finally, he's going to talk about dimensionality reduction. All right, so big data visualization. What is it? When you ask people what big data is, you will get all sorts of different answers. Yeah, so that's a really fuzzy term. And the question is, so first, I really like this quote by Dan Ariely, who is a professor at Duke. He used to be at MIT Media Lab. And he actually said, big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. And I really like this because it hits the nail right on the head. So it's fuzzy, but there are definitions out there. There is no perfect definition, yeah, that's for sure. But this one is at least better than just talking about the amount of data. It's the 4 V's of big data defined by the Gartner Group. And it used to be the 3 V's of big data, but they extended it because they actually didn't cover an important aspect. So the first V would be data volume. Yeah, that's probably the most intuitive one. When you think about big data, it's always about the volume. Yeah? So and this is a moving target. Yeah? So we started with megabytes at some in the early days, then moved on to gigabytes. Nowadays, probably terabytes are big, but for some fields like astronomy or so, there you have like exabytes of data. But this is moving, so every year this is increasing. Yeah? This is what people usually tell you when you ask them what big data is. Then there is data velocity. Yeah? That's also a really interesting aspect. So if you have a static data set, if you have a table which stays the same, then it might be it is much easier to analyze than a stream of data, which is constantly changing. Yeah? If you parse data from a Twitter stream or some other data source and you want to analyze it on the fly, then this gets much more complicated. Yeah? That's the second V. The third V is data variety. And this is probably, so for my research, this is the most interesting one, I have to say. It's about homogeneous data versus heterogeneous data. So in homogeneous data, you really, if you take a table, if this is the data that we analyze, and all the columns, they have the same type, then you just represent them using a heat map, for instance. Yeah? But if you have heterogeneous data, so if you have multiple tables with a different meaning, different semantics, you additionally have like graph data, you have text data, and you all need to you need to merge this to actually solve one particular problem. Yeah? And this is what makes it really hard. It's the data variety. And the fourth one is data veracity. Yeah? This is, if we have data that is 100% sure, then it's much easier than to look at uncertain data. Yeah? If we consider biology,